This is another variety of question that I want to talk about. Okay, this is called grid problem. This is something called grid problem. Okay, some people call it grid problem. Okay, some people call it, for example, in ISC we call it okay highway problem basically. Okay, anyway, the name does not matter. Basically, the point is this. For example, if you have this, let's assume this is your highway or this is a grid. Okay, maybe this is a highway. Okay, and you can notice that. Okay, so maybe this is a grid or something. Okay, now let us assume that you are here. Okay, so you are here, and from here you want to go here. Okay, at this point you want to go. Okay, so let me do this. Okay, so you want to go here. Then how many ways are there basically? And the condition is there. What is the condition? You can go one step up or you can go one step right. So basically this is the, okay, like you cannot go left. For example, if you are here, you cannot go left, you cannot go down. So this is the point. Okay, in every step you either can go up or you can go left, right. Okay, so in every step I can say, in every step either go right or up by one step. Okay, so this is one step. So I can say this is one step. So tell me, in this question, can anyone tell me how should I do? How many ways are there to go from here to here? For example, this is way. Okay, for example, this is way one. I can say I can go like this. I can go like this. Okay, what I can do? I can go like this. Then I can go like this. Then I can go like this, and then I can go like this, and then I can go like this. This is it. This is, I can say this is path this is path one. Okay, another path I can take is maybe this. Okay, for example, another path I can take is this. I can go like this, like this, like this, like this. Okay, so this is your path 2. So you can notice like this. So how many paths are possible? The point is this. Okay, so number of paths that are possible means number of ways you can go from here to here. Okay, so now let's see this. What is the answer here? See here, one thing you should note is that, okay, we can prove something here. Some very nice point we are going to prove here. See, let me tell you that if you are going here from this point, if you are going here, then how many right move you have to make? Okay, whatever path you take. For example, if you take this path 2, then this path 2, I can say that you have taken up, okay, right, up, right. Okay, so this is your path 2, means up, right, up, right. Okay, so this is your path 2. And what is path 1? Path 1 is right, up, path 1 is right, up, right, up, right. Yes or no? So I can say path 1 is this one, right, up, right, up, right. Okay, and this is your path 2. So similarly, I can say that whatever path you take, I am saying that whatever path you take, for that path, how many this type of sequences you will get? How many you are basically how many sequences you can get? Tell me. Is it possible that you can get multiple sequences for the same path? Is it possible? Tell me. Is it possible that for the same path you can get more than one sequences like this? It is never possible, right? Whatever path you take, for every path you will get exactly one sequence of u comma r, I can say. Okay, so this is the first observation. So you can notice the observation 1. What is that? For every path, I can say from initial to final, this is your initial, this is your final. Okay, from I to F, I can say for every path exactly one, I can say, okay, exactly one sequence of u comma r of how much length? Okay, so you can notice that exactly one sequence of u comma r we will get. Exactly one sequence we will get. We will not get more than one. We will get, okay, for every path, whatever path you take. For example, if you take this path, then what this means? This means right, up, right. Okay, so for every path, what you are going to get? Exactly one sequence of u comma r we will get. Okay, and this sequence this sequence we will have, in this sequence basically you will have how many? You will have 4 right and 3 up. Basically you will have 4 R's and you will have 3 U's in this sequence. Okay, so this is the first observation. This is the observation number 1. And what is the second observation? Observation number 2, what is that? That is that if I give you a sequence, okay, for any sequence, I am saying, okay, for any sequence, if I give you a sequence for any sequence of 4 R's comma 3 U's, this is the observation that we can make. For any sequence, whatever sequence you take of 4 R's and 3 U's, we will get a path from I to F. Yes or no? Is this true? We will get a path. We will get exactly one path from I to U. We will get exactly one path from I to U. Because whatever sequence you take, if you take any sequence, that is your choice. Okay, if you take this sequence U R, then you will get a path. Okay, so for this sequence you are getting a path. For this sequence, this is the path. You can notice like this. Okay, like this you are getting a path. Okay, this is your I, this is your F. So whatever sequence you took, U R. Okay, U R. So for this sequence also you will get a path. Okay, U R. So you can notice. Okay, 1 2 3. Okay, yes, correct. So you can notice that you are getting a path. So this is the point. So finally, from these 2 observations, what we can, okay, so I can say this is the point. Okay, so this is the observation that this is your path from I to U. This is your path from I to F. Okay, and this is your sequence. This is your sequence of 4 R's, 3 U's. Okay, so finally I can say that there is one-to-one correspondence. There is bijection between them. Yes or no? There is bijection between them. If you have a path P1, then there is a one-to-one. There is exactly one image here. For every path, you have exactly one sequence here. You have exactly one sequence here. Okay. Similarly, you can notice for every path exactly one. Okay. So there is a, and similarly, if you have a sequence here, R, U, okay, R, U, R. Okay. So you can notice if you have, then again exactly one path you will get. Do you agree or not? So this is from these 2 observations, this is what we can see. So I can say there is a bijection. There is a bijection between them. So number of path is equal to number of sequences. Yes or no? So there is a bijection. Agree or not? Because for every path you have unique image here, and for every sequence you have unique path. Yes or no? For any sequence you have unique path, and for every path you have unique sequence. So what I can say, tell me? Can anyone tell me what I can say? So there is bijection. So there exists a bijection between what? Between number of paths from between set of paths, I can say. Okay, between. So there exists a bijection between set of paths from I to F and set of sequences of 4 rights, 3 ups. So finally I can say, and when you have bijection, then what happens? Can anyone tell me? If there exists a bijection between set A and set B, then what happens? Tell me. If there exists a bijection between set A and set B, if there exists a bijection between set A comma set B, then there exists a bijection between set A and set B if and only if their cardinality is same. If and only if their cardinality is same. Their cardinality must be same. Okay, so there exists a bijection between set A and set B if and only if their cardinality is same. So here the cardinality must be same. So I can say number of path is equal to number of sequences of 4 R's and 4 U's. So finally, how many sequences are there? Just count it. So finally, this is this is the final conclusion. Number of paths from I to F, this is equal to number of sequences of 4 R's 3 U's. Yes or no? 4 R's right and 3 up. Okay, so that's it. That's it. So this we can very easily calculate. Yes or no? Actually, this is our target. The question is asking this. Now, to find this, we can very easily calculate this. And what is this? Can anyone tell me? 4 R's 3 U's. So this is 7 factorial divided by 4 factorial 3 factorial. Yes or no? How many sequences are there in which you have 4 R's and 3 U's? Can anyone tell me? Can anyone tell me how many sequences of 4 rights and 3 U's? How many sequences are there? Basically, it's like R, U. How many permutations? Number of permutations. What is that? Means how many sequences? Means number of permutations. That is 7 factorial divided by 4 factorial 3 factorial. How can I prove it? See, okay, very easily you can get it actually, because all you have to do 4 R's 3 U's. Okay, so what you can do? What you can do is just select positions. You have total 7 positions. See, you have total 7 positions. 3, 4, 5, 6. Okay, you have total 7 positions. From 7 positions, select 4 positions for R. You have total 7 positions. Select 4 for R. Let us assume I select this, I select this, I select this, I select this. Now, automatically in the remaining position, you will go. Automatically in the remaining position, you will go. Okay, so from the 7 position, select 4 position for R. Automatically in the remaining position, you will go. Or from the 7 position, select 3 position for U. Automatically in the remaining position, R will go. Okay, so that's the point. So answer will be 7C3. Okay, so this is the answer, 7C3. Is this clear to everyone? This problem, this grid problem, this highway problem, is this clear? This observation is clear or not? That there is a bijection between this proof. This is the proof, remember. And if you know the proof, then you can handle any type of question. If they give you some variation, I don't know what they will give you. The GATE exam, they can give you anything. We don't know. But if you know the proof, then definitely you can handle it, because you know why it is coming. Now you know why this formula is coming. Okay, so like this you can just very easily do. Okay, so you can just try this this variation, you can try. So let's assume like this you know. Okay, and from this point you want to go, from this point you want to go to this point, and you can only go up or right basically. Okay, the only move, okay, either move right or up, either move right or up. Then tell me how many ways are there? Either move right or up by 1 step. Then tell me how many, what is the answer? So here, what is the answer? Very simple. First of all, you can only move right or up. Okay, so you can never go here. At this point, you can never go. You can never go, because if you go here, you can never go here, because you can only move right or up. Okay, so once you go here, you can never go here. So finally, answer will be what? Okay, so how many horizontal moves you have to make? 1, 2, 3, 4. 4 horizontal moves and 3 vertical moves. 4 horizontal, 3 vertical moves you have to make. Okay, so finally I can say 4 right moves, or I can say horizontal moves. 4 right moves you have to make, and 3 up moves you have to make. Okay. Now, so finally answer will be 7C3. Okay, so this is the answer. Like this you can do. So can you try this question? This is GATE 2007 question. Suppose that a robot is placed on a Cartesian plane. Okay. At each step, it is allowed to move either 1 unit up or 1 unit right. If it is at ij, then it can move to i+1j or ij+1. How many paths are there? Distinct paths are there. Okay. So there for robot to reach the point 10, 10, starting from the first initial position. Okay, so here what is the answer? The answer is quite very simple. that basically you have this Cartesian plane. Okay, on this Cartesian plane from 0, 0. From this, you want to go to 10, 10. Okay, so this is your 10, 10. You want to go to 10, 10 from 0, 0. Okay, and you can notice at each step, you can basically go either up or you can go right. Okay, at each step. For example, this is 0, 1. Okay, sorry, this is actually this is x if this is the x-axis. Okay, if this is your x coordinate, if this is your y coordinate, then this is basically 1, 0 like this. Okay, and this is basically 0, 1. If this is your x coordinate, this is your y coordinate, then it is like this, something like this. Okay, anyway, so finally what I want to say is how many horizontal move, how many right moves you have to make, and how many up moves you have to make. Just tell me this, that one. Okay, so you can notice that total 10 horizontal, 10 right moves you have to make. Okay, so here from here you want to go here, so 10 right moves you have to make and 10 up moves you have to make. So finally our answer will be what? 20C10. Why 20C10? Because see, remember 10. Okay, so total 20 position you have. Okay, there are total 20 positions. There are total 20 positions you have. From these 20 positions, you can select 10 position for R. Automatically in the remaining 10 position, you will go. Okay, so like this, you can say answer will be 20C10. Answer will be option A. Can you try this question? This is small variation. This is small variation. The question is saying that basically the robot cannot traverse in the line segment 4, 4 to 5, 4. So the robot cannot go from 4, 4 to 5, 4. Robot is not allowed to traverse the line segment from 4, 4 to 5, 4. Okay, so there is a 4, 4 here. Let's assume there is a, this is 4, 4. So there is a 5, 4 here. So you can notice this is 5, 4. Okay, and this is your 0, 0. And this is 10, 10. Okay, so basically you cannot go here. I can say this is broken. This is broken. Okay, so you cannot go here. So okay, you cannot go here. With this, what is the answer? You cannot go here. Remember, you cannot go here. So again, the answer is very simple, because you cannot go here. And in India, what happens? Actually, not in India, in world, in the whole world, it happens that if someone tells you to not do something, then you will do it. Okay, so do that. Okay, basically that is the rule. The robot should not go here, so just go here. Okay, so that's the point. Just go here. Means basically total case, desirable cases. Finally, I can say that desirable cases is equal to total cases minus undesirable cases. Okay, so what are the total cases? This we have already seen, right? So this is 20C10. This is the total cases. Undesirable means go to basically take this. Basically take this 4, 4, 5, 4 line. Take this line. Okay, so if you are taking this line, then what it means? If you are taking this line, then what it means? See, if you are taking this line, it simply means that you are going at 4, 4. So first you are, okay, somehow you are going here. Okay, so how many ways to do this? How many ways to do this? 4, 4. So this will be 8C4. And then you are taking this, and then you are going here. How many ways to do this? Tell me. So you can notice 5 right moves you have to make, 6 up moves you have to make. So that means basically 10C, 5 right moves you have to make. Okay, 6. So that means basically 11C5. Okay, so this means 11C5. I can say this means 11C5. So finally you have to multiply them, because you have to do this, you have to do this, you have to do this. These 3 things you have to do. So finally answer will be okay. So here answer is going to be, okay, undesirable cases 20C10 minus, that will be 8C4 multiplied by 11C5. Okay, so this is the answer. Okay, so like this you can do this question, and this is a popular problem. Remember, this is a popular template. Okay, how 8C4. See, if you if you want to take this line, then what you have to do? Just tell me this point. If you want to take this line, then you have to go to 4, 4, right? First, you have to go to 4, 4. First, you have to go here. First, you definitely have to go here. There is no other way. You have to go here. Then you have to take it. And then you have to go to 10, 10. From 0, 0 to 4, 4, how many paths are there? From 0, 0 to 4, 4, how many paths are there? That is because from 0, here you have to make 4 right moves you have to make, and 4 up moves you have to make. Yes or no? Is this clear? You have to make 4 right moves and you have to make 4 up moves. So that is the reason 4 right moves, 4 up moves. So that is the reason 8C4. Why 8C4? Because 4 are for you. See, from here you want to go here. What it means? You have to make 5 right moves and you have to make 6 up moves. 6 step upward and 5 step to the right. So that is the reason. Okay, 11C5. Okay, is this clear to everyone? This is a standard university problem. Okay, so here you have 2 more variations basically. Okay, some more variations you will find here. So can anyone tell me the answer now? Okay, some more variations are there, are present. Find how many different routes are there without restriction. How many routes are there without restriction from A to B? And you can notice you can only go either downward or you can go to right. Okay, so either you can notice either you can go to downward or you can go to right. Okay, so this is a popular problem. Remember this grid problem. This is a very popular problem, very popular combinatorics problem. Okay, so what is the answer for option 1? So you can notice 1, 2, 3, 4, 5. So this is actually 6 by 4. Yes. So this is basically 6 by 4. 6 down moves you have to make. 4 up moves you have to make. So you can notice 6 down moves. Okay. 6 down moves you have to make, and 4 right moves you have to make. Okay. So total 6 down moves. I can say down moves means 6 down moves you have to make. Okay. And 4 right moves you have to make. So total how many permutations are there? Means in any order you can make, because in whatever order you make, you will go to from A, you will go to B. Okay. So how many permutations are there? So the answer is 10C4, because total 10 positions you have. So I can say total 10 positions you have. From these 10 positions, you select 4 positions for R. I can say select 4 positions for R. Okay. So select 4 positions for R. That means 10C4. In the remaining position, automatically D will be there. Okay. So this is the 10C4 for this. What is the second? If you must pass through C, you must go through C. Okay. This point, you must go through this point. So then the answer is very simple. If you have to go through this C, then for the second problem, so what you have to do? From A, you have to go to C. From A, you have to go to C. Okay, and then from C, you have to go to B. Okay, so this second problem. From A, you have to go to C, and from C, you have to go to B. Now, from A to B, you can notice 2, 2. Okay, 2, 2. So basically, if you want to go here, then you have to do 2 right moves and 2 down moves you have to make. And here, how many? So 2 right moves and 4 down moves. Here 2 right moves and 4 down moves you have to make. Okay, so you can notice here how many ways you have. So 4C2 ways you have here. Now once you are here, then how many ways you have here? 6C2 ways you have here. Okay, so finally I can say then answer will be 4C2 multiplied by 6C. Okay, so this will be the answer. 4C2 into 6C2. What is the answer for option for statement is 3 for the question number 3? If you cannot move on the top line, basically this line you cannot move. Okay, don't go. Basically, don't go here. This line you cannot go. What it means? Can anyone tell me? If you cannot go here, what it means? It means the first move has to be down move. The first move has to be down move. Yes or no? So the first move has to be down move. Yes or no? First move has to be down move. Okay. So basically you have to start with the down move. Once you are down, once you are here, now the question is very simple, A to B. So, okay, once you are here, then the answer is very simple. What is that? 9C4. Okay. So basically 9C4. This is the answer. Okay. Because you can notice first move has to be down move. Okay. Then I can say that 5 down moves you need. Okay. Then 5 down. Okay. And 4 right moves you. So that will be 9C4. Okay. What is the answer for the fourth? If you cannot go in this line, don't go in this line. Basically, in this fourth option, this line is prohibited. Now, what is the answer? Here you can create cases actually. Okay. See, you can create the cases. What are the cases you can create? Case 1. What is the case 1? You start with the down move. If your first move is down move, then what should be your second move? Can anyone tell me? If your first move is down move, then what should be your second move? It has to be down. It has to be down. There is no other choice. Okay, so you can notice if your first move is down, then automatically it has to be down. Now the remaining. Okay, what is the remaining? The remaining. Okay, once you are here, then basically this is just a 4-4. Means basically this is 8C4. Okay, so in this case 1, basically you have 8C4. What is the case 2? Case 2 is you make right move, then you make down move. Okay, you make right move, and then you make down move. Then what should be your next move? Can anyone tell me? If I make right move, then I make down move, then the next move has to be down again. It has to be down. Now what is the answer? Now the answer is 7C4, I think. Yes or no? Now the answer is 7C4. Now case 3. What is that? You make right move, then you make right move, then you make down move. Now it has to be down. Now it has to be down. Okay. In this situation, what is the answer? Right move you make, then down move you make. Now it has to be down. Okay. And finally, right, down, it has to be down. Here you have only one way. Okay. Here, how many ways? Right, down. Okay. Right, down. Here. Okay. So that will be 5C. What is that? 5C1, 5 ways. Okay, so that is 5C1. Is this correct or not? Is there any doubt? Here it should be RR D. So basically this should be 6C2. Okay, I think 6C2. Okay, so you can make it 8C4, 7C3, 6C2, 5C1, and then 4C0. Okay, so this is your answer. Just add all of them. That is your answer. Yes or no? Is this clear? Is this question clear to everyone? So this is just another variation. Okay, anyway, you can handle all these type of questions.